Hello and welcome everyone. So I'm going to explain what this lecture is in just a second, but you see this 9 and 10. This is referring to Varian Chapter 9, Technology, and then Chapter 10 has to do with costs. This lecture is basically, this mini lecture is basically bridging the gap between our understanding we're developing around production technologies, typically our output as a function of two inputs, maybe labor and capital, and the groundwork that we built in the principles level class, actually, where we think about total costs, average cost, variable cost, fixed cost, marginal cost, all as a function of quantity. And so what I'm going to do here is I'm going to build to the idea, the takeaway point that actually the costs that we're familiar with, all those costs written as a function of quantity, the cost curves even, in fact, that we graph and build, are direct consequences of the firm's production technology, whether it's Cobb-Douglas, perfect complements, perfect substitutes, or whatever. So we have some production technology. We introduced this in Chapter 9 in Varian, or wherever we are in the intermediate micro course. And lots of times we'll be solving problems where we're separating out our costs between some variable component, typically labor, and some fixed component, typically capital. Maybe using a different convention, you have like some omega 1, which is the factor, the price of factor 1, and then you'd have like an x1 here, or omega 2, and then you'd have like x2 for factor 2. And if we're thinking about cost this way, it's really useful to separate out our cost into a variable component and a fixed component, because that allows us to think of the short run world and go to the long run world, and it's all great, except for how does this link back to like marginal costs as a function of output, or average total cost as a function of output? Because remember, when you graph average total cost, you have that nice U-shaped curve, and it's going to be crossed from below at its respective minimum by marginal cost, same for average variable cost. Like, what on earth does that have to do with our production technology that we've got here? And I'm going to point out it has everything to do with it, in fact. So we'll get there. First, let me kind of introduce or remind us of the definitions of marginal product and how we get those, and then short run, and we'll build our logic around this kind of generic example. Then I'll have a couple more specific examples yet to come. All right, so we've got our production technology. We want to get our marginal product of labor, our marginal product of capital. Marginal product is just how much additional output do you get when you use one more unit of the respective input. So the marginal product of labor is if I hire one more labor hour or one more worker, how much additional output do I get? Right, so the idea is maybe I've got a pretzel cart and I want to see how many additional batches of pretzels do I get if I hire one more worker, especially if I just have a cart and no workers. I don't have any pretzels, but if I hire somebody now, maybe they can produce like 2 or 3 batches for me. Okay, so the marginal product of that first worker is the 1 or 2 or 3 batches that they produced by virtue of us being able to hire them and employ their labor, right? Marginal product of capital, this is how much additional output do I get when I hire one more unit or employ one more unit of capital. This could be like one more machine or something, right? So maybe I've got my worker and I need to clear a parking lot, right? I've got a snow removal business. I've got a contract to clear this large commercial parking lot. If I get one snowplow that my driver can drive, now I'm able to clear one parking lot in whatever is the time period. So the marginal product of that additional snowplow might be like one cleared parking lot. Okay. For simplicity, I'm going to assume capital is fixed. If I write K upper bar, well, we write K upper bar to indicate that we fixed capital. And so actually, if you just saw this production function, this is like the generic production function, and without further information, you might even just interpret this as a long run situation where all the costs are all the factors are variable. This situation, because clearly capital is fixed, we'll interpret this as a short run situation. Okay, I'm going to focus on the short run version because think back to the principles level economics course where we had our cost curves, average variable cost, average total cost, marginal cost. That was the short run cost curves. And so we want to live in the short run to build this intuition. All right, so I'm going to build from marginal product, which we just introduced, to the idea of marginal revenue product. So let's just reflect on the questions that these things are helping us answer. If we want to answer the question of how much output is produced when hiring one more unit of labor, the answer is look at your marginal product of labor. To calculate that, we take the partial derivative of our production technology with respect to labor. Right, so I'll take the partial derivative of this thing with respect to labor. That's my marginal product of labor. I take the partial derivative of my production technology. It's a function of labor and capital with respect to capital, and that'll give me my marginal product of capital. Sorry, I meant to say that before. The question, the second question is, what's the value of this additional output, right? These are two separate questions. How much additional output, like how much physical output do we get when we hire one more unit of labor? That's marginal product. How much physical output do we get when we hire one more unit or employ one more machine or whatever, unit of capital? That's marginal product of capital. What's the value of the additional output? That's a different question. Now we have to multiply that additional output, that marginal product, by the price of that good in whatever is the final goods market, right? So if I'm making pretzels, my marginal product of the first worker that I hire might be 2 batches of pretzels. Maybe each batch is like a dozen or something. I'm making my example more complicated than it needs to be. Maybe the market price of each dozen is something like, I don't know, $20 or something, right? So if I get one additional batch of pretzels when I hire each additional worker, that's my marginal product of that worker, one batch. Maybe it's like a dozen pretzels. What's the value of the additional output? Well, I have to multiply that one batch by $20, right? So it's going to be, well, $20. It's going to be the marginal revenue product. So what's the value of the additional output produced? Multiply the marginal product of labor by the price of the output, P, to generate the marginal revenue product, which is going to be written as P. That's the price of the good that they're producing in its market by the marginal product of the factor. And that'll give you the marginal revenue product. Right? Okay. What's the additional cost of obtaining this additional output? That's interesting. So like the marginal revenue product is like the benefit of hiring one more worker, right? We get this additional output and that output has some value. We measure that value by the marginal revenue product. What's the cost of getting the additional output? Well, so this is going to be tied to the wage. Not directly one-to-one, but it's going to be related to it. So I'll develop this with some examples. If we assume capital is fixed, as we are here in the short run, then the cost of obtaining the additional output is going to be the cost necessary to hire that labor to produce that output. So I asked the question, is it simply wage? Is it simply W? Well, wage is the cost of one unit of labor, so 1L basically. When L rises by 1, firm's going to incur that wage for each additional unit L that it's going to hire, right? So if I set L at 1, I'm going to pay the wage once. If I use 2 units of labor, I'm going to pay the wage 2 times wage. If I hire 3 units of labor, I'm going to pay the wage 3 times, right? So the idea is, suppose I've got this commercial contract to clear a parking lot of snow. Maybe my production process requires 3 workers to be able to clear this parking lot. Maybe it costs me $10 as the wage to hire 1 worker. Well, the marginal product of each worker that I'm hiring is 1/3 of the parking lot, but I have to hire 3 workers. So the cost of the additional output is the 1 cleared parking lot, is, well, the labor cost of those 3 workers. So $10 for the first one, which gets me 1/3 of the parking lot cleared, $10 for the second one, which gets me the second third of the parking lot cleared, and then $10 for the third worker, which now clears the entire parking lot basically. Okay. Right, but we have a cleaner way to be able to relate these things. So by employing, importantly, such as was in the example with this parking lot, simply employing 1 more unit of labor doesn't mean the firm gets exactly 1 more unit of output, right? I hired 1 more worker and I get like 1/3 of the parking lot cleared. It's not 1-to-1. I mean, maybe if I hire 1 worker for my pretzel cart example, I get exactly 1 additional batch of pretzels. So that's good. That's 1-to-1. But, or at least in the example, maybe they produce 2 batches or 3 batches, but if you get 1 additional unit of output, then sure, for each additional worker that I'm going to hire, the cost of that additional output they're getting me would just be the wage. But it could be the situation such as like in this parking lot example where I have to hire several units of labor to get 1 additional unit of output. So there's some subtlety here. The unit of labor might make many outputs, or it might make a fraction of the output. So the 1 unit of labor that I'm hiring, the 1 worker, maybe they make 2 batches of pretzels, or maybe they only make a fraction of a cleared parking lot in the snow removal example. Importantly, we want the cost of the labor only to produce the first unit of output. And importantly, increasing the unit of labor, or the amount of labor we're using, is going to incur that cost, wage, W. Increasing the amount of labor, one more unit of labor, is going to give us the marginal product, so we're going to get the benefit, right? So on the plus side, when I hire one more unit of labor, I'm going to get the marginal product of that labor. On the cost side, I'm going to incur one more wage cost, right? And then overall, if I want to find just the cost per unit, in other words, the cost per marginal product of labor, this is going to be defined as marginal cost is equal to W divided by the marginal product of labor. Right? So the marginal cost of just that unit is going to be wage divided by marginal product of labor. Okay. So the marginal cost is wage divided by marginal product. For instance, if it takes 3 extra units of labor to produce one more unit of output, the marginal product of labor is 1/3. That's like my parking lot example. I had to hire 3 workers, presumably or hypothetically, to get one cleared parking lot. The marginal product of each worker was 1/3. So the wage divided by 1/3 is going to tell me I'm going to pay 3W for that wage, right? That's this right here. So another 1 unit of labor gets the firm an additional 1/3 units of output, for instance, implying that marginal product of labor is 1/3. If, like I said previously, maybe the wage is $10, then the marginal cost of 1 hour of labor is $10, but the marginal cost of 1 additional unit of output, like the cleared parking lot when I have to hire 3 units of labor, is going to be $30. Right? So this marginal cost right here is not the marginal cost of labor. This is the marginal cost of 1 more unit of output, like the cleared parking lot. Took 3 workers to clear it. I'm going to have to pay them each $10, so the marginal cost of cleaning that parking lot is $30. Using the formula, the wage is $10, the marginal product of each worker is 1/3. 10 divided by 1/3 is 30. All right, so it works. If it takes 3 hours to get 1 unit and labor costs $10 per hour, then the marginal cost of the extra unit is $30. So I mean for this to be if it takes 3 labor hours, or like I'm getting the labor of 3 workers basically. And labor cost, the wage is $10 per hour, then the marginal cost of the additional unit I'm producing was $30. Okay, so here's that example, like more carefully, my snow removal business. So consider a snow removal business has a contract to clear 1 large parking lot for a local business. Parking lot's large, so the work requires 3 workers. Then the marginal product of each worker is 1/3 of the parking lot. So the marginal cost of clearing 1 additional parking lot is going to be, well, 3W, right? Marginal cost is wage over marginal product of labor. Wage is just W. In this case, marginal product of labor was 1/3, so I'm going to incur 3W. Or if W is 10, like we've been using, then I'm going to incur a marginal cost of $30 to clear 1 more parking lot. In other words, the total labor cost to clear the parking lot is the wage W paid to 3 workers, hence the 3W. Okay. Here's the other example, the pretzel business. So consider a pretzel cart business that hires workers to produce and sell pretzels. Suppose each worker is able to help the firm produce 2 additional batches of pretzels. I want it to be 2 instead of 1, so you can kind of see how the numbers would work. 1 kind of hides the number because 1 falls away actually. So the marginal cost of 1 more batch of pretzels is going to be W over MPL. Well, wage is W. The marginal product of each worker was 2. So the marginal cost of 1 more unit of pretzels, 1 more batch of pretzels, was W over 2. Look what's going on here. The marginal product of each worker is 2 batches of pretzels. So the marginal cost of 1 batch of pretzels is half, right? So I pay the wage, but I only actually needed to pay half the wage, or hire the worker for half an hour rather than the full hour to get that 1 batch of pretzels. That's not quite how it works, but officially, but think about what's going on here. The difference between the 2 was each worker was producing only a fraction of the completed output in the parking lot example. However, each worker in the pretzel example is producing multiples of output. So that's why my marginal cost is going to be lower. Each unit of labor, which costs the firm W, helps produce 2 batches. So the total labor cost to get 1 additional batch of pretzels is W over 2. Okay, so now I'm going to go and I'm going to think specifically in the context of the cost example. Oh, I have a typo here. This should be K. I typed this way too fast. Or maybe this should be K, sorry. Of course it is, right? Because here Q is going to be 2 times the square root of labor times the square root of capital. So let me see if I can just drop this in real quick and try to write this, just because I know if you're looking at this, we want to make sure that we're on the same page. This should have been that. Okay, sorry about that. I'll see if I can adjust that, although not for the purposes of the video here. All right, we're assuming wage is 1 and rental rate of capital is 1. We're fixing capital at 64. What's the rental rate of capital? Well, see, we want to be able to come up with a way to think about comparing the cost of labor and the cost of capital. And so, well, the cost of labor, each additional unit of labor, we're going to pay the wage. That makes sense. What about this R? Well, I like thinking about this as the rental rate of capital. So this is like maybe the opportunity cost or like the price of capital. Sometimes you could think about this in terms of like maybe the wear and tear or depreciation of our machine or something like that. Alternatively, you could think about, well, we've got this capital that we could have sold or we could rent out. So there's generic or there's store brand versions of products. And whatever is the store, Target or Walmart, or pick your favorite like big box retailer, they're not making oatmeal, for instance. And they're not making, well, milk or cereal or anything else that you're buying from their store brand. Instead, what they're doing is they're finding the factories or the manufacturers that are producing those things, and they have a contract with them to on, some portion of the day or for some entire days or whatever, some runs of the factory, they put the Walmart or the Target or whatever store brand label on it, is the idea. So rather than making, I don't know if this example exactly works, but rather than making like Quaker Oats brand oats, you'd make maybe Target, I forget what their store brand is, and then you put their label on the oatmeal instead, right? So in some sense, this is the opportunity cost, the rental rate of capital. And all that does is it justifies us putting labor and capital in the same part of the equation. Okay, so here's the setup for the problem, and I'm going to say, all right, can we go from having a Cobb-Douglas production technology to finding fixed cost, and average fixed cost, and variable cost, and average variable cost, and marginal cost? These are all functions of quantity, but this thing is quantity in terms of labor and capital. So how in the world does this work? Well, all right, so we can get the fixed cost immediately, right? We're fixing capital at 64. That's what this K upper bar means. We fixed the capital. We're holding capital constant at 64. The rental rate of capital, the price of capital was 1, which means 64 times 1 is the price of using those 64 units of capital. The total cost of using capital, the fixed cost, is going to be $64. Great. If we divide that by Q, that gives us our average fixed cost. Just like any other average fixed cost, this is going to tend to 0. It's going to approach 0 as quantity gets really big. What about variable cost, average variable cost, and marginal cost? Well, to do this, let's just go to our short-run world, right? Because these are short-run costs. And so let's fix capital at 64. That's nice because the square root of 64 is just 8 times 2 is 16. So Q is going to be 16 times the square root of labor. Great. If I solve this for labor, this gives me labor in terms of quantity. And the interpretation here is important. This is the labor cost necessary to get Q units of output. Right, so if I want to get Q units of output, how much labor am I going to be? How much labor do I have to use? L units. Maybe it's a little bit misleading to say cost. Labor cost would be officially W times L. This is like the labor demand. This is like how much labor do you need to hire to get Q units of output. That's what I should say there. Okay. So just bringing this back up to the top of the page. If I want to find variable cost, that's going to be, well, W times L. And L is as a function of Q. We just found this right here. W is 1. So 1 times this right here is going to give me my variable cost. So that's Q squared over 16 squared is 256. So sure enough, this is a variable cost curve. Or variable cost. If I divide that by Q, the Q cancels, and I'm going to get Q over 256. There's my average variable cost. If I add this together with if I add that Q over 256 to my 64 over Q, that will give me my average total cost. And then to get marginal cost, I can take the derivative of variable cost with respect to Q. So that's going to be 2Q over 256 or Q over 128. Sure enough, marginal cost as a function of quantity is going to cross average variable cost from below at its minimum. Well, here they're going to share a point, and that's going to be the origin where Q is 0. All right, so what's the marginal product of labor? Well, the marginal product of labor, we saw that already. It's the partial derivative of my production technology with respect to labor. So if I take the partial derivative of my production technology with respect to labor, it's going to be this. Here, I have to take this 1/2 times this 2. So 1/2 times 2, that's just going to go away. That's just going to be 1. And then I'm going to reduce this power by 1. So it's going to be L to the minus 1/2. And then this K to the 1/2, well, that was actually 64, square root of 64. Or that was actually 8, which comes along for the ride. That's this part right here. All right, so what I'm going to get, marginal product of labor is going to be 8 times L to the minus 1/2, right? Actually, this should just be 64 to the 1/2. Sorry about that. So that's a little bit confusing. So let me write out more carefully the marginal product of labor, MPL. Sorry, I know if I type this might be loud on the microphone. So this is going to be L, let me just write the line that I have, 2L to the minus, whoops, it's one of these, isn't it? It's 1/2. 64 to 1/2. That's what that should be. That's huge. Sorry. All we need is for this to be positive. Right there. Okay. So marginal product of labor, this cleans up real nice. This is going to be 8 times, well, that's 1 right there. So it's going to be 8 times L to the minus 1/2. Okay. And then what's the wage? Wage was just $1. So marginal cost, using our formula, marginal cost is going to be wage divided by marginal product of labor. So 1 over this stuff, which is going to be the square root of labor over 8. Well, hold on a second. So back up here, I said marginal cost is Q over 128. And down here, I'm saying marginal cost is square root of labor over 8. So wait, what's going on? Looks like we have 2 different marginal costs. No, they're actually just the same thing, but written differently. So what's going on, they're giving us different information, the information in kind of a different format. So marginal cost equals Q over 128 is giving us the marginal cost at Q units of output. Marginal cost equals the square root of labor divided by 8 gives us the marginal cost at L star units of labor. But presumably, my Q units of output require L star units of labor to produce it, and vice versa. Right? So it's going to give me the same thing. And sure enough, I can set them equal and show that they are the same. So if I set these things equal and cross multiply, oh, before you know it, I just get our short run production function back. Right? So this was our short run production function. Okay. So sure enough, our cost curves, our marginal cost, our average variable cost, our average total cost, average fixed cost, all those things are inherited directly from our production technology. So that's the link. Indeed, our cost curves come from your production function. Okay. Hope you found this useful. I'll go ahead and conclude here. See you in the next one.